Okay, level 4, number 3. Here we have a horse and an ox that are pulling something up an inclined plane. So let's just draw the plane and let's just put the object here. It doesn't matter who does the pulling. The force applied on this object is going to be the same no matter what, because that's based on all the net forces, the force of gravity, the normal force, the frictional force, and all of that. And if you work this out, you can figure out what F applied would be, and it wouldn't matter if it was being applied by a horse, an ox, you, or a mouse. It doesn't matter. It's the same amount of force that's required. And so that's all we need to know. We don't need to figure it out. We just need to know that it's the same. It's the same pull required by the horse and the ox because they're both pulling the same object up the same slope. So now let's think about how we describe the power. Let's do the power of the ox. The power of the ox. Power is the change in energy over time. Now, there's many ways to talk about the change in energy. You can change the EG, you can change the EK, you can subtract them, but don't forget that work equals the change in energy over time. And so what we can write here is the power of the ox is the work done by the ox over time, and that equals work is force times distance over time. So what is the ox doing? Well, he's using that applied force that we talked about, and he's pushing a distance, and his distance is 80 meters for the ox. And the time that he does it in is 90 seconds. So we have this. Then if we do the same thing for the power of the horse, it's again the change in energy over time. But change in energy is the same as work over time, and that's the same as force times distance over time. So for the horse, the power of the horse is the force applied, the same one, times the distance the horse is able to go, which is 60 meters, and the time, which is 50 seconds. So now here's what we have. We have this for the power of the ox, and this right here is the power of the horse. So let's just put them beside each other, not in an equation, let's just compare them. Here's the power of the ox, right? F applied times 80 over 90. And the power of the horse, F applied times 60 over 50. Now, F applied is the same in both cases. So in a sense, it doesn't have any effect, does it? It's the same number for both. So what we really have here is we have an F applied multiplied by an 80 over 90 and an F applied multiplied by a 60 over 50. Well, it doesn't matter what number the F applied is. If it's the same, this is the number that will make the two answers different. So the bigger one is going to be the most power because we're multiplying it by the same F applied. 60 over 50 is a bigger number. You don't even have to figure it out. It's a bigger number than 80 over 90, right? 80 over 90, the small number is on top. It's less than 1. So this is a smaller number, whereas over here, 60 over 50, the bigger number is on top. That's greater than 1. So we could write that down. This one, 80 over 90 here, whatever, less than 1. This is bigger than 1. So if you take a number called F applied, you multiply it by something less than 1, and then you take that same number and you multiply it by something greater than 1, well, which one is going to give you the bigger answer? Obviously this one, the horse. So therefore, the horse has more power because the horse pulls, he doesn't pull as far, but he does it much more quickly. And power is all about the rate at which you change